Welcome back. This is episode number 18, Common Patterns, where we're going to look at map again. We're going to dive just a little bit deeper into map, and you'll see what we mean here in just a bit. I'm Reed Evans. I'm on Twitter at ReedNEvans. So in episode 17, we talked about that map was something that all functors have. In other words, to be a functor, a type, or it has to implement this function signature. So given a function from A to B and a functor of A, return a functor of B. And as we talked about, arrays are functors, and because arrays are functors, that's why we can map over them. So in other words, array is our functor, so if we were to write map out for arrays, we wouldn't need this functor of f, because that doesn't have to be generic. And we would say, given a function from A to B, which is our increment function, an array of A's, then we can return an array of B's. So that ends up working just fine. But it's very, very common as you get into doing some more stuff with functors to end up having functors of different functors. And so in this case, our either array here is saying we have an either of an array of integers. So we're nested two levels. So can we still use our increment function that we have here when we're two levels deep? Like, how do we deal with things that are two levels deep? A common thought is to, once something gets into a context, to pull it back out of that context as soon as possible. But as we've seen in other videos, that kind of defeats the purpose of having values in these contexts. So what we want to do is keep the values in the contexts, and we want to use our patterns, map being one of them, to be able to deal with those. So in this case, we have an either of an array of numbers. And if we come down here, we can see that, well, the simple way to do it, we're nested two levels deep in functors here. We just call map twice. So we call map on either array, which maps into the either, because either is a functor. And once we've done that, now we have an array of numbers. Inc works on numbers. An array is a functor. So we can map again. And as you see up here, we get either right of 2, 3, 4. So we were able to take the same increment function and be able to work on it on an either of an array. So we were two functors deep here with the value that this increment could work on, but it worked fine. We just call map twice. Very simple. So we take it one step further. What if we're three levels deep, right? If we have a maybe of an either of an array of 1, 2, 3, it's a bit contrived. I'll give you that, because there's probably not a value in doing maybe of an either. But what you will see often, which you will probably see often if you do this enough, is the concept of future, because you may return an array back, or you may get some errors, you may get some other stuff like that. And so the concept of a future of an either of an array or something like that, those sort of things may be more real world than what this is. But in this case, just showing you that it really doesn't matter what it is. We really don't care that it's a maybe of an either of an array. If we want to modify the underlying array that's three levels deep, all we have to care about is the fact that we're nested three levels in functors, and because we're three levels in functors, we can call map 3 times and then pass our increment function, and we get a maybe just of an either right of our array of 2, 3, 4. So it still works. We don't care anything about the fact that this is a maybe, this is an either, etc. The implementation of functor for each of these things will handle all of that for us. We don't have to deal with that. We just know that we're 3 levels deep in functors, and what we want to do is we want to increment this array. And so we can say map, 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 inc, and it ends up working. This has been Common Patterns, map. This is our second look at map and how we can use it for deeply nested functors that in this case are of different types, and it ends up still working fine because we're dealing with the fact that they're functors rather than that they're a specific instance of functor like maybe or either. Once again, Common Patterns Map version 2. I've been Reed Evans. Thanks.